Welcome to 204B Part 4, where we're going to talk about two construction aspects of our relays and our contactors that really improve the efficiency and effectiveness of those devices. Within the coil assembly of a contactor or relay, we have our core material, which the coil is wrapped around. The construction of the core is very important, and we use two techniques in order to improve the efficiency as well as the reliability of our relays and our contactors. And we're going to talk about how laminations and shading coils affect the operation of our relays and contactors. We're going to start with laminations, and we have discussed laminations before in theory. If we remember our magnetic theory, we know that anytime that we have a changing magnetic field going across a conductor, we're going to create a current flow inside that conductor. Now, if we think of our core material as one large short circuit, that coil that's generated inside that core can create a lot of heat. This is where our laminations come in. Our laminations are thin sheets of iron or steel that are electrically insulated from each other, and the purpose of that is to reduce the current flow that's inside the core material. With an AC system, the magnetic field that is created is constantly changing. So in a relay, the coil is constantly inducing a voltage inside the core. And whenever we have a voltage and a complete path, we do create a current. With a solid core, a lot of current is being induced inside there. But since the magnitude of the current is proportional to the area, having laminations limits the area while not affecting the magnetic properties of the whole core. So even though there are more eddy currents, the smaller area means smaller currents as a total. And since we have less current, we have less heat buildup, which also means less power losses inside our core. The other design difference that we have is called a shading coil, which is basically a continuous loop of copper that's embedded into the pole face of the armature, and it's done at 90 degrees to where the laminations are. The purpose of a shading coil is to reduce chattering inside the relay. We have to remember that whenever we are running a current through the coil, it is creating a magnetic field that's in proportion to that current. And as my current crosses the zero line, my magnetic field also is reduced to zero. What this can do is it could allow that armature to release and engage and release and engage, which would create a chattering effect. By adding a shading coil to my core, what I end up doing is I end up adding a secondary current through that shading coil as well. And since the shading coil is positioned in a different direction than what my core is actually positioned, it creates an offset to that secondary current. So not only do I have a current in my main magnet coil, I also have a secondary current going through my shading coil. And that creates an offset where now I don't have any blank spots or any zero values to my magnetic field, since I never have a true zero value inside my core. You've reached the end of 204B Part 4. Make sure you go over the purpose to laminations and shading coils to the point where you can fully understand what their purposes are and how they're operating within the total system. After you're comfortable with this information, continue on to 204B Part 5.